Okay, so now we are going to discuss the rest of the things. So good evening. So mostly it will be good morning. I think it will be uploaded in the next day. Okay, so what are the things we have concluded? Okay, slideshow from the current slide. Okay, so this is what we are going to discuss. Now our topic is about functional units. Okay, I think I have already covered in the previous class, but once again I want to repeat the things. What is meant by functional units? And one more thing, you are very much familiar about all these things, but my concept is to just give an introduction, or what you can just give a little bit of knowledge once again on this topic. Okay, so what are meant by functional units? The name itself indicates that by using that particular units, we are going to perform particular function. Okay, so each unit has a special or specific function. So if you consider any input IO devices, IO unit, so here the function of this particular IO unit is either to take the input values or to give the output values. Similarly, the function of a memory is to store the data and give the data to the devices whenever there is required. Generally, a memory device will store the data when we perform any operation. Okay, and it will give the data to the arithmetical and logical unit whenever there is a requirement. That means whenever if you want to perform any addition between you need at least two values now. If you want to perform either addition or subtraction or multiplication or division, whatever it may be, so you need at least two values. Okay, so those two values will be provided from the memory, and once if you perform an operation, whether it is addition or subtraction, you will get some result. Okay, the result will be stored in the memory. It may be stored in the register or whatever it may be, but finally it will be stored in the memory. So that is the purpose of memory. So as we have discussed in the last class, memories can be classified into two types: primary memory and secondary memory. Okay, next the other component is arithmetic. So primary memory and secondary memory, I have given the differences now. So what is the difference between primary memory and secondary memory? So here it is, I think. Okay, we're having two types of memories: primary memory and secondary memory. So what is the difference between these two? Primary memory is, the name itself indicates that this is the basic memory or inbuilt memory, the memory that is present along with our computer. That means whenever you purchase any laptop or tab or PC, whatever it may be, along with that particular computer, there will be some memory that will be provided to you. It will be referred as primary memory. Okay, and what is mean by secondary memory? The memory that is that the user is going to interface externally is referred as a secondary memory. Okay, that means the memory, the best example for the secondary memory is your pen drive. Okay, whenever you inserted a pen drive, you can access the information that is present in the pen drive. Actually, it is not the internal memory. It is the memory that is present from the external. So that is one of the example. Okay. Next, CDs, DVDs. These are the examples for the secondary memory. So that is about the memory unit. Okay. Next, we are having ALU, arithmetical and logical unit. So what is mean by arithmetical and logical unit? All the arithmetical and logical operations are going to be performed in this particular ALU. Okay, so how it is going to perform the operation means it will take the inputs from the memory or from the registers, either from the memory or from the registers. It is going to take the inputs and it is going to process that particular data and it is going to give the desired output. It is going to give the output. That is the purpose of ALU, arithmetical and logical unit. It is going to perform the arithmetical as well as logical operations. And one more thing that is present is control unit. The name itself indicates that it is going to control all the features or all the characters. So that is the purpose of this control unit. So these all will come under the functional units. So functional unit means each unit has a specific function to perform. So it will be referred as a functional unit. Okay, now next slide. So this is what we have discussed. Next concept is basic operational concepts. What is meant by this? It is somewhat new concept is new. What is meant by basic operational concepts? So here it is a combination of two terms. Basic means general. Operational, that means in order to perform any operation. Who will perform this operation means ALU. That's what we have discussed previously. That is the main reason why I have discussed about the previous slide one more time. Okay, basic operational concepts. This topic itself indicates that we are going to learn about the operations that are going to perform in general. Okay, who will perform? What are meant by operations means these are nothing but addition operation, subtraction, multiplication, or shifting the data from to the right side, or shifting the data from to the left side, or rotating the data, whatever it may be. These all come under the category of operations. Okay, so just before we have discussed in the entire block diagram, where it is, okay, in the entire functional unit block diagram, who is responsible for performing any operation? Did the IO device performs any operation? Did the input device performs any operation? Or did the output device performs any operation? They don't perform any operation. The main thing is they will just take or give. That is the thing only. They don't add two values or subtract two values, multiply two values or shift the values. They just takes whatever that will be given by some other, the output unit or the input unit will receive something given by some other. Okay, so that is about these functional units. Okay, so among all these functional units, who will perform this basic operation means the basic operations will be performed by ALU. Okay, okay, how can it perform this operation? How can, for example, if I want to add two numbers, how can it know that it needs to be two numbers are going to be added? Means for that purpose we will write a program. Here in CAO you are having only small programs, but in the next sem you will have MPMC, microprocessors and microcontrollers. In that MPMC you are going to have big programs. Okay, so there will be a separate unit which consists of mostly the programs, and you are having MPMC lab also where you will go work with the programs. Okay, so how can we perform a required task? That means I want to make the processor to perform addition. How can I make it to perform addition? Means I need to write a program which will be understandable by that particular processor so that it can perform the desired task. If I want to perform some multiplication operation, then also I need to write a program so that the particular processor will perform the required multiplication and gives the output. And you also, it is your responsibility to even specify where the obtained result is going to be stored. Okay, that is also your responsibility. If not, it will be stored in somewhere where it is what you will call comfortable to the computer but not to you. Okay, that means if you are downloading any document or from the internet or something, it is your responsibility to select a folder where it is going to be stored. Okay, that means mostly it will be stored in the downloads, but it is your responsibility to give the name of a folder where it should be stored. Okay, here also the basic operational concepts means what they are going to discuss mostly is, in order to perform any task, okay, you need what we need. A program consists of list of instructions. What is mean by a program? So in order to perform any operation, you need to write a program. Okay, it is well and good. What is mean by program? The standard definition of a program is nothing but set of instructions or group of instructions. Okay, the set of instructions or group of instructions is referred as a program. Okay, that means in order to perform any task, you need to write some group of instructions. Okay, here also we need to write a group of instructions. Okay, it is well and good. I have written some group of instructions. What is the next thing I have to do? Before execution, first of all, I have to store that program. Isn't it or not? So that is the second thing what we are going to do. Okay, first we will write a program, then we'll store the program, and we next, the third thing is we will execute. Okay, whenever we execute, we will automatically get the output. Okay, but there is some internal process that is going to be happened. For example, if I want to add two numbers 8 and 9, okay, take two numbers, or if not, take two numbers 2 and 3. If I want to add the two numbers, one is 2 and the other one is 3, how can I add these two? It is not like performing some addition in our calci and entering 2 and plus symbol and 3 and entering and pressing on is equal to will give 5 as output. Okay, but how it is going to perform internally means, internally they should be stored in different registers or different memory locations, which are to be stored. The values what we are going to add or subtract or whatever it may be, they should be stored in a register or a memory location. Okay, that means the 2 has to be stored in a register or a memory location. See here, you all are familiar about registers. That's why I haven't given much more explanation. You are very much familiar about the register concept in your STLD. So registers are nothing but group of flip-flops. What is a flip-flop? Flip-flop is a single bit binary data storage device. Flip-flop is a single bit binary data storage device. Okay, group of flip-flops is called as a register. So if you consider a register size as 8-bit, that means there 8 flip-flops are being arranged in a sequential manner. Sequential means ఒకదాని పక్కన ఒకటి. Okay, each flip-flop will store only 1 bit of data. That means if the register is of 8-bit size, that means 8 flip-flops are being arranged in a sequential manner. If it is a 16-bit register, that means 16 flip-flops are arranged one by one in a sequential manner so that it can store 16 bit of data. Okay, so that is the concept. Okay, next what they are going to tell. So what is the main concept means? So in order to perform any task, here the program, okay, so what is the main thing I am going to tell is, in order to perform any operation by the ALU, arithmetical and logical unit, it needs inputs. The inputs will be stored in the memory, either in the form of registers or directly in a memory location. So you need to take those particular inputs from that memory locations. Okay, later on we are going to perform the required task. For example, my program consists of 20 instructions. Each instruction has specific task. Okay, if I write a program for addition in 10 lines or 10 instructions, each instruction has a specific task. Okay, na? So one by one, the tasks are going to be performed. Then only you are going to get the correct answer. That's what the entire thing about. So overall, the basic operational concept means how we are going to perform any operation. The main concept is, see, I am giving a conclusion about this whole basic operational concept slide. Okay. First of all, in order to perform any operation by using a computer, you need to write a program for that. Okay. First of all, you need to write a program. Program is nothing but group of instructions. These instructions will be stored in the memory. While executing that particular program, because you will get an output only after executing the program what is written by you. Okay. So for best example, if you want to convert a Word or PDF to Word document or Word to PDF, first of all, what is going to be asked? For example, if I want to convert a Word document to PDF, first it will ask upload a Word document. Okay, you will upload. Then it will ask you have to click on download, convert into PDF button. Okay, afterwards you will see something like this. Okay, some circles like this. That means it is performing the operation. Their execution is being going on. There is an internal program that is written in order to convert your Word file to PDF file. Okay, whenever you click on the convert to PDF, Word to PDF button, there will be an internal execution that is going on, that is not being watched by us. Okay, that is an internal program that will not be visible to us. Okay, na? So here the main concept is, whenever you are executing the program, while individual instructions will come one by one. From where they will come means they will be stored in the memory. So from memory they will come to the ALU and they are going to be performed the operation. That means whenever I want to add two numbers, the two numbers will be stored in the memory. From memory they will come, they will reach the ALU. The ALU will take those two values and it will perform the desired operation, whether it may be addition or subtraction, whatever it may be. Okay, that's what the second fact means. Individual instructions are bought from memory. They will be bought from the memory because the program is nothing but a set of instructions. The instructions will be stored from in the memory. So whenever you want to perform a task, it should be come from the memory into the memory while performing the specified task. Specified task means it may be addition, subtraction, multiplication, division. Okay, so that is the main reason why I have given a lot of introduction for this slide. Okay, because you should be familiar that what is meant by a register. Registers are nothing but group of flip-flops. Next, what is meant by a program? Program means group of instructions or set of instructions. Next, where the program is going to be stored? It is going to be stored in the memory. From where the ALU will get the inputs? It is going to get the inputs from the memory. Okay, so that is the concept. Next, so here this is the main architecture, or this is the connection between the processor and the memory. What is meant by a processor means central processing unit. Okay, so here see control unit and ALU, these together, ALU means arithmetical and logical unit, and control unit, these together will form a processor. Okay, so, okay, whatever it may be, connection between processor and memory. So how the processor and memory are going to be connected? Okay, here see in the central processing unit itself, they have mentioned some more components other than what we have discussed in the basic block diagram 3 slides or 4 slides before. Once again I will show you. Here if you observe, the processor consists of only control unit and arithmetical and logical unit. But in this diagram, if you observe, along with this control unit and arithmetical logical unit, there are some more components that are added. What are they? See, except those two, the rest of the components or rest of the blocks that are added, all are registers. All are registers. Now we are going to discuss about those registers one by one. Okay. Before here, the main aim of this concept is how the processor and memory are going to be connected. Okay, here this is the main memory, and here this is the processor. It is connected by using some symbol. So if you observe here, there are three symbols, right? In the slide, I'm showing you now. So this is one, this is one, this is one. What are those three means? Those are buses. Those are buses. What is mean by bus? Okay. The main definition of a bus is nothing but a group of bytes. Bus is nothing but a group of bytes. That is the physical definition of a bus. A group of bytes is called as a bus. Okay, well and good. What is the function of a bus? The function of the bus is similar to the function of the bus what we are using in our real time. So in our real time, we are using RTC buses, college buses, city buses, whatever the bus it may be, either it is luxury bus or whatever it may be, tourist buses, whatever it may be. The main purpose of the bus is just to transportation. The main purpose of any bus, whatever it may be, school bus, college bus, RTC bus, whatever, private, local or city bus, whatever it may be, the main purpose of using the bus is transportation. Okay, there the people are going to be transmitted from one place to another. Some buses, along with the people, they will carry the goods also. Here also the same thing. The buses are used to transmitting the data from one place to another place. So just in the previous slide, we have discussed very clearly that programs are stored in the memory, but in order to perform any operation, our ALU needs information. That's what we have discussed now. In order to perform addition, it needs some data between whom it has to perform that addition. If you want to perform any subtractions, it needs some clarity between whom it has to perform that subtraction. Okay, for that particular purpose, we will use these buses. With the help of these buses, the data will be exchanged between the memory and the central processing unit. So between CPU and memory, the information will be exchanged with the help of these buses. Okay, that is the main purpose of these buses. I think now you are very much clear how the data is going to be exchanged. First of all, whatever the program you have written, it will be stored in the main memory. It is going to be accessed one step, instruction by instruction, not all the instruction at a time. Okay, so whenever we are executing a particular instruction, move AX, 50H, this will be these instructions you will get in the next units. Okay, move AX, 50H. AX is the name of a register. 50H, hash 50H, for example, construct 50H. 50H is a value. So AX register, in AX register, you have to transmit 50H value. Okay, how it is going to be executed? It is going to be executed by using ALU. Okay, the ALU will perform that particular operation, or if there is an instruction, add AX, BX. AX has 30 and BX has 20. Okay, here instead of mentioning add 30, 20, we are giving some register names or memory locations like that. Okay, this concept will come or will be familiar with the next units. No problem about it. Okay, just to know what is the main thing you have to concentrate or you have to learn is from main memory to ALU, the data will be transmitted to these buses. Okay, here if you observe these two buses, these are two-way arrow mark symbol. That means they are bidirectional buses. They are bidirectional buses. What is mean by bidirectional? That means using that particular bus, you can transmit the data from main memory to our processor, and you can also transmit the data from our processor to main memory. That means two-way communication is possible with these two buses. Okay, but if you observe this last bus, which will be indicating by me with the pointer, mouse pointer, this is only one directional bus. That means it is only used to communicate in only one direction, that is from processor to main memory, but there is no two-way communication. Okay, so that's one, that is about the buses. Okay, now we are going to discuss about the extra components that are present along with our main processor slide what we have seen previously in the functional units. So previously, if you consider the CPU, it consists of control unit and ALU. But if you observe here, along with this, it consists of registers, 8 general. I see here R0 to R of n minus 1 general purpose registers, MDR, MAR, PC, IR. All of these are registers. Okay. So now we are going to discuss about them. Okay. I think next, what is the time? I think, wait. So, video.